Welcome everyone to today's lesson, and today we're going to be covering the topic of flowcharts. Now this is another way of planning our code, and we're going to have a look at this a bit more clearly in the second slide, but I just wanted to make clear what our lesson objectives are today. So our first objective is to understand why we use flowcharts as programmers, and the second objective is to learn which symbols we use to create these flowcharts, these diagrams of code. So if we look at this flowchart on the right hand side over here, which I'm circling like this, I don't know if you have noticed yet, but this flowchart represents an algorithm. Whether that algorithm is complicated or simple or useless doesn't really matter right now. The point is it represents an algorithm. It does something by following a series of instructions. Now the key word here is the series, the sequence of instructions. And the way that we identify what the sequence of instructions are with a flowchart is by looking at in which direction these arrows are pointing to. So unlike traditional code, so if you're looking at pseudocode, for example, or actual high-level code like C# over here, it could be Python, it could be JavaScript, doesn't really matter. You would know the sequence of instructions by looking at which instructions come first before others. So for example, this for loop here will definitely be executed by a computer before this, or will have been looked at by the computer before this. Why? Because it's before it. So with programming, instructions run in this direction. Yes, we have loops that then bring it up again, or you may have go-to commands which skip to certain parts of the code. But the way that you look at sequencing with pseudocode or high-level code is by simply following the code going down. With flowcharts, if you look on this side here, so if you look at this arrow right here, it's not pointing down. So with flowcharts, it doesn't necessarily mean that the arrow has to be going down for the code to be going in a sequence. As long as you're following the arrows, then you are able to trace the flow of the program. And we're going to talk about this a little bit more in the next slide. So just before we move on to the next slide, a bit of a challenge for you here. Here's a question for you. Can you identify which parts of the flowchart here, so this is the flowchart if you haven't guessed already, which parts of the flowchart relate to the code in, well, it says C++ here, apologies, so this should actually be C#, like so. So which part of this flowchart relate to the C# code here? So if you want to tackle this challenge on your own, you don't have to fill anything out, just use it as a mental exercise. You can pause the video. I'm going to give you the answers in a couple of seconds, but if you want, you can pause the video now and then I will give you the answers. So pause if you wish. Alright, let's have a look if you guessed them correctly. So we have the declaration here of a variable, and we have its assignment to 0. So we've declared the variable I, and we've assigned it to 0. In the flowchart, we can see that that instruction is being accomplished with this shape, with this rectangle on the top here immediately after the algorithm starts. Because if we look at the C# code here, as soon as the for loop is initiated, the first thing that happens is all of its variables, because you can put more than one here, all of its variables are initiated and they are assigned to a certain value. Now, the second part of the for loop, the condition, which is this part right here, which checks whether I is less than 10. So if this condition is true, then everything inside the brackets, which is encapsulated inside the brackets, will be executed. So, this condition right here is being checked in the flowchart with this diamond shape right here. Then what we have is, in the for loop, we have this iterator right here, this incrementer, which is incrementing I by 1. But if we look at the flowchart, that's not what's happening next. What's happening in the flowchart is actually the instruction is being executed inside the for loop, and then we can see that I is being incremented by 1, which matches this part of the for loop here. So because this is a high-level language, and we will be learning about what makes up a high-level language in the future, but because this is a high-level language, sometimes the way you write things is a little bit more abstract than how you would write it normally. So this flowchart here explains clearly how a for loop actually works. If its condition is met, if it's true, then it follows the path of yes, like so, and it will output I. It will then increment I by 1. I will go back to the condition to check it again. So when it goes back, I would be equals to 1. Again, this condition would be true, and it would be stuck in a loop until I is finally 10, right? So I will constantly be incremented, and when I becomes 10, this condition would then become false, because if I would be 10, 10 is not less than 10, so this would be false. It would then follow the path of no, and it would stop the algorithm. Just the same as the for loop. Once I reaches 10 and this condition here becomes false, then it would skip its encapsulated code here, and it would either continue with other parts of the algorithm, or in this case it would stop completely. Alright, so have a look at this for yourself. Rewatch the video if you have to. This is just sort of the intro to the intro. We're going to get into a bit more detail in the second slide, in the second part, so see you then.